Welcome to a rare Saturday edition of Forecast Lab. As you can see, there's not much weather going on in our area. Well, we have had a frontal passage and some thunderstorms down in the Houston and San Antonio area. A lot of that missed us. But let's take a look at the surface map and we'll see right where that front is. And this is the early evening analysis, and yeah, there's that cold front right there from about Lufkin, maybe all the way down to San Antonio there, but you can see it's banked up against the mountains right there. Not quite to Albuquerque, but it is along the Front Range. Out to the west, though, some very hot conditions, 109 at Phoenix, and look at that dew point, 66. That's way up there. You know, they always say it's not the heat, it's the humidity. Well, now they have the humidity. 109, 66, that's going to feel bad. 64 at Lake Havasu with 112, which is also bad, but you can see how rapidly it dries out as we get towards Barstow, where it's 112 over 17, and a little bit of a heat wave there on the lee side of the Sierra Nevadas, 108 there at Bishop, 109 at Bicycle Lake, or I think that's China Lake, same general area, and 97 up at Tonopah, and even hundreds all the way up into southeastern Oregon. And yeah, 101 at Salt Lake City, 103 at Wendover. Yeah, this is a bit of a heat wave, and 111 at Las Vegas. I think that's probably most of the important numbers there. So we got ourselves a heat wave. Well, here's the satellite loop. Run that forward and kind of see the progression. And obviously, we're under northwesterly flow in the Four Corners area and much of the southwestern U.S. So it's a good sign here that the subtropical high has backed off and we're under a progressive westerly flow, westerly and northwesterly. There's conditions in the northwestern U.S. Again, progressive flow out of the west. However, I think we've got ourselves a ridge kind of in this area right there. Out to the west, systems are moving out of the southwest, and on the east, they're moving out of the northwest. Some anvils that are sheared over pretty well there in Wyoming. There's the weather map in the northwestern U.S. We've got a cool high-pressure area across the Canadian prairies there, driving northerly flow into Dakota, North Dakota, and Minnesota there. And then on the west side, we've got the return flow, southeasterly flow setting up in Montana, and there it is, bringing warm weather on up into Alberta. Also very warm in the Washington area. They've got 94 there at Omak, 89 at Spokane. And that's about all the important stuff I see. Let's take a look in the northeastern U.S. Well, we've got a frontal system there in the Cincinnati area, cold front extending down into Tennessee and Kentucky, and a warm front east into the Appalachians there, West Virginia and Maryland. North of that, some very mild air with 70s, and the dew points are still up there, so we haven't really cleared out the old air mass too much. And you can see a little bit of a wraparound there with rain on the backside in Indiana. Up to the north, it looks like things have cooled down a little bit there. 81 up in Quebec and Ontario. And the surface map definitely showing that frontal system. There you go. There's that comma cloud. You know, it'll show better on the infrared imagery. And out ahead of it, some very unstable air. That outlines most of the thunderstorm activity centered in southern Ohio, the Pittsburgh area, West Virginia there. And let's switch over to the infrared channel. And there we can see that comma cloud coming together. I'm going to outline that. In fact, some of it probably goes all the way to the Great Lakes, but that's it right there. That indicates probably a shortwave trough out in the Paducah area, out to Tennessee. And there it is on the GFS, right there. We're going to keep that in that region of fast flow where the black height contours are close together. We don't actually bring that up into this area because the flow tends to be pretty weak there. And it's advection which is really important. The advection is a lot stronger in this area, so if we have a vorticity gradient, like in this region right here, then we're going to see vorticity advection be a little bit more enhanced close to that region. So very weak advection up to the north, very strong advection within the stronger upper level winds. And that's helping to produce a lot of the strong dynamic lift we see there in Indiana and east central Illinois this evening. And in the southeastern U.S., we can see the remnants of that front there in Louisiana and South Texas. And off the Florida coast, down in the Bahamas, we've got Tropical Storm Isaias. And there's the NHC plot there. That's going to be, looks to be maybe east-southeast of Miami, maybe about 200 miles or so. 60-knot winds, so it's on the threshold of hurricane strength. And there's the official forecast there, forecasting strengthening into a low-grade hurricane sometime this evening, grazing the coast into tomorrow morning and going right up there through Vero Beach, Titusville, and weakening into a tropical storm. And then we see it cross over into the Carolinas on Tuesday, and we should have a pretty big rain event there along the coast. And there's our surface map for the southeastern U.S. Southwesterly flow, maritime tropical air mass across Georgia and Alabama. And then down in the Bahamas, right about there, we can see the circulation with Tropical Storm Isaias. I'm going to go with maybe right about there. None of the synoptic wind stations showing a whole lot of wind. There's 33 knots right there, 21 in Miami. And that's pretty much what we expect with these types of tropical storms. Not much of a wind radius on it, but we should see those winds start to increase in the Palm Beach and Miami area this evening. Here's a look at what we're going to be seeing with the winds according to the GFS model. GFS has been pretty good with this track, so I'm going to use this as a baseline. And then we see 0Z, storm approaching the coast, still some distance there from Miami. And yeah, the 15-knot winds, that looks about what we're seeing there on the surface network. 6Z, that's going to be about 2 in the morning. We can see it approaching the coast there. That looks like around Palm Beach. Looks like maybe sustained 35, 40-knot winds. And then by 12Z, which is about 8 a.m. tomorrow morning, it's grazing the coast. Looks like maybe some effects there from friction as we see mostly 20-knot winds along the coast. And there's 18Z, there's 2 p.m., and then 0Z pretty much heading up towards the Kennedy Space Center area. So bearing that in mind, let's take a look at the rapid refresh panels. This is from the operational inset model, and we'll take a look at the actual wind gusts determined by the model. 10-meter wind gust, that's what we need right there. Now, as long as this model is in line with the GFS, I think we can use it for our forecast. This is not a model that's designed to forecast hurricanes. However, it is a convection allowing model, so as long as its track is in the ballpark, then we should have a good modeling of the wind field, and that's kind of what I'm counting on here. So starting at about 8 p.m., we can see that there's a very compact eye wall there with gusts up to maybe 85 to 90 knots. And then running that forward, you can see those gusts start approaching the coast. It looks like 35 knots up there from Palm Beach down to Miami about midnight. Then about 4 in the morning, we start to see some of these 45-knot gusts coming on shore around Palm Beach to Port St. Lucie. Around 8 a.m., Yep, some of it coming inland around Port St. Lucie. That looks like maybe about 45 to 50 knots. We do have to be kind of careful not to split hairs on this. And then towards the end, there at 9 a.m., looks like about 45 to 50 knot gusts right along the coast. So according to this model, it looks like the hardest hit areas will basically be from about Palm Beach up to Port St. Lucie and Vero Beach. And then after that, we'll see how things go for later tomorrow. And then looking at reflectivity, yep, there's a storm moving up the coast, and a lot of the dry air being entrained there from the inland area is probably taking a toll on the storm. But do keep in mind there are hurricane warnings up and down the coast, so there is the potential there for unexpected development. So to my viewers who are tracking this storm, I want to invite you to do something tonight. This will help you learn a little bit about how these models work with these hurricanes. Go to this high-resolution rapid refresh and look at the fields of wind and reflectivity, and then see how they match up to radar. Take a look at the forecast from like 3 to 12 hours out, and then see how it verifies. According to the surface plots, you can see the wind gusts right here, and also look at the reflectivity observed by the radars. Now bear in mind that some of the reflectivity is going to be out of range. This is the Miami radar, so a lot of this will be outside the region of coverage. But as this approaches the coast, take a look at the high-resolution rapid refresh and see how that compares with the observed data. And I guarantee you, you will learn a lot from that. This will give you insight into how well the mesoscale models are handling a real-life hurricane event. And you'll be able to see if the wind gusts were close to what was forecast. And since models are the wave of the future, it definitely helps to have a good baseline for how well they are handling situations like this. And it can be as easy as going into this matrix right here. And there's Palm Beach. It's indicating 35 to 40 knots. So it can be as simple as looking at the 3 a.m. observations and see, are they getting 35 to 40 knots? That's stuff you can do tonight. Probably better than just looking at the talking heads on the news. Okay, let me go ahead and get this wrapped up and posted. Thanks for watching the Forecast Lab program, and we'll see the supporters on Monday and the rest of you all on Tuesday. Have a great weekend. Bye-bye.